Okay. I now want to think about the material that is at the heart of your next Excel assignment. And in doing so, I'm exposing a pattern for you. So the material that we've gone through the last 2 weeks is what lets you have the tool set to do this week's Excel assignment, which is due now or tomorrow night, right? What we're talking about tonight will help you do the next Excel assignment. And that's pretty much going to be the way it is. And so if you will replicate the Excel assignment, it will then help you do the problem sets and the homeworks that are starting to come at you. I believe this week for the first time you have the practice homework and homework number 1, which are due a week from now. So this structure that I'm about to show you in Excel is the structure you'll use for Excel assignment 2. And once you've got Excel assignment 2 put together, that will help you do the problem set, the ICPs, and you can then use that structure once you better understand it. Having done the problem sets, you can then use it for the practice homework and the homework assignments. And the homework assignment is one that has some persistent scoring that has meaningful impact on your grade, right? So these are not accidentally put together this way. Do the Excel assignment, then do the problem set, then do the practice homework, and then do the homework. If you do the practice homework, you'll do the homework much faster. If you don't do the practice homework, then it'll just take you longer to do the homework, okay? But do the others first. They are the foundation for the ones that count. Okay, so I want you to look at something here with me. I'm about to introduce a couple of issues here, and I do this in what I call a multi-columnar valuation structure. And I'm going to show this to you in Excel. You can do it with algebra, and I'll show you where the algebra fits in. But you're going to do this in Excel because it just makes it easier. And my sense is, as professionals, you'll virtually always have Excel available to you, or some like-minded tool that becomes increasingly more sophisticated and intuitive, right? So what we have here is a base year. So think, and I believe I'm not using Mira-Dravana here, okay? I'm just using some numbers. So any correlation they have to Mira-Dravana is simply coincidental. So I'm calling 2019 the base year. And the base year is the year for which we already have full accounting data. It's over. It's in our past. It's done. Shouldn't be 7 or 8 months ago. It shouldn't be 10 months ago. It should be fairly recent. It's our base year, and we're always going to think of that as time 0. So in the Mira-Dravana case, I believe that I give you 2018 and 2019. So 2019 is the base year. 2020 then is year 1. And then 2, 3, 4, 5, and so on. Notice that I'm calling as the explicit period those years that I am doing some explicit forecasting for. And you'll see how this comes together when I show you the functions in Excel in a few minutes. And what I've done is I've taken the free cash flow I've taken the free cash flow from my base year, which I'm not showing you, but it would show up on the base year's income statement and balance sheet. And I'm expanding it at some rate of growth to get to year 1, year 2, year 3, year 4, and year 5. And so let's look at what the rate of growth is. How can you tell by looking at these numbers what the rate of growth is that I'm using?
You can subtract the current from the previous and divide by the previous. Is that right?
That's exactly right. We commonly refer to that as P2 minus P1 divided by P1. It's the percent change equation you've seen many times. So if you look at each of these, you can identify the percent change. In this first year, I used a percent change from year 1 to year 2 of 9.7%. Let's see what I used in the second year. So 2.35 minus 2.14, so P2 to minus P1, divided by P1, or 2.14, and there I use 9.8%. So I'm not using a constant growth. So I have expressly or explicitly forecast the expected rate of growth of this company's cash flow variable, and I've used a number of inputs to do it. I've looked at the marketplace, I've looked at the economy, I've looked at our growth plans, I've looked at new products we have coming out of development. I've looked at, did we suffer a coronavirus or have we been spared that pain? I looked at all these things. I got Taylor and David and Michael and Diana, my chief senior VPs together, and we looked at each year. We looked at our customer patterns, we looked at new customers, we looked at marketing images, all of this. And we'll go into more detail about how we'll do that next week. But I didn't just put, this is a 9.5% growth or 10% growth. I've expressly or explicitly looked at that. And I've done that for a 5-year period. And you would find that the rate of growth in these 5 years is all just a little bit different one year from the next. But they're all around 9 or 10% because I got my best minds together and we think that's how we're going to be able to grow during those years. But then I looked at Taylor and said, Taylor, how are we going to grow for year 6? And Taylor threw up his hands and said, Rick, I barely understood how we were going to grow in year 5. I'm not going to venture a guess in year 6. It's just too far away. And when he did that, David Bradshaw said, and because of that, since we don't have a credible crystal ball in front of us, we're going to go ahead and put some very nominal rate of growth. So what was that nominal rate of growth? Well, I can calculate it by taking 2.92 minus 2.85, which is 0.07, divided by 2.85, and it's 2.46% is what I calculated as our long-run expected growth rate. Some very nominal, very vanilla pudding growth rate. Okay? So I have my free cash flows. I've got an explicit period of time. I've got a cash flow in year 1 for this CV, this continuation period. I'm calling these years 1 through 5 the explicit or express periods. Explicit forecast, express forecast periods. And then I'm calling the next year, year 1. Well, if this year, 2025, if it's year 1, what will I call the year 2024? If 2025 is 1, what is 2024, Kylie?
0.
0. 0. So you think, well, wait a minute, Rick, it's year 6, it's not year 0. What you're about to be exposed to is we're going to think of time in 2 different temporal signatures. We're going to start counting time from our base year forward, but at a point at the end of our explicit period, the period in time which we think we have some credible chance of being right, then that last year of that period, we're going to start counting time over. And that last year becomes year 0, and the next year is year 1. Does that make any sense to anyone with half a brain? One of the smarter guys I know is Shenzheng. Shenzheng, is this an easy concept to get your head around?
Yeah, kind of.
I'm glad it is for you, man, because most of us mortals struggle with it, okay? I want you to think about counting time from 2 different perspectives. It's going to help you in thinking about how we construct valuation models, okay? Well, in this case, all it's done is it gave me the ability to have a CF1 or cash flow or beta at time 1. Time 1 being the year following the years of my explicit period. Well, I'm going to take my summation, the sum of the present values of my free cash flows during my express or explicit period. How do I get them? Well, I take the present value of each of the free cash flows. How do I get those? I take the free cash flows and divide them by 1 plus my discount rate, in this case 16.95%, to the power of time. I like seeing it all laid out like this. I could do all of this in a single cell in Excel, couldn't I? It would be a honkin' cell with lots of parenthetic statements, but I could do it in one cell. I don't want to. I want you to see what's going on here, okay? So in this case, I have calculated my free cash flows. I discount them at a discount rate. I then have a running total of those. So 1.66 plus 1.56 equals 3.23 plus 1.47 equals 4.7, and so on until I get the sum of the present values. And then I'm putting that number right here. Okay? That's the easy part. The next part is, how do I get this number, 20.2? Well, what I'm going to do is there's a lot of ways I could think about having come up with it. I'm going to show you in an Excel model that I'm going to come up with this continuing value, which I get by using cash flow from time one and dividing it by R minus G in a Gordon growth model construction. And that gives me some number. But when does that number live? Does that number live today as a present value Carol? Or since I used a number in the future to get it, does it live in the future? What do you think? It lives in the future. So let's think back to Gordon growth. This is no longer CF1. It is in continuation time, but when did cash flow in time one come to us? It came to us 5 years out. So we have to think about that. So we're going to have to discount it back that 5 years. So this continuing value, and by the way, this is all a little bit of review from the time value of money videos still. This continuing value is going to be calculated using the Gordon growth model, and then we're going to take a present value of it. Well, how do we get a present value? We take some future number, and we just agreed that this number exists in the future, and we discount it by dividing it by 1 plus a discount rate to the power of time. Well, in this case, how many years in the future will we discount it? Any ideas? Will it be 6 years in the future? Will it be 4? Will it be 5? What do you think? Well, let's look at something real quick. Look at the time signatures. Continuing value at time 0 is equal to a cash flow at time 1 divided by R minus G. So as we come back to our slide, when is time 0 here? If this is the cash flow at time 1, when is time 0? If that's time 1, when is 0?
2024.
2024, Diana. So if we use the cash flow from time 1 and divide it by R minus G, so 16.95, and I think I said it was 2.46 was the growth rate, R minus G, we're going to then get 20.20. But that number is CV0, or value at 0. That was the Gordon growth model, wasn't it? The value at time 0 is equal to some cash flow at 1 divided by R minus G. Well, if I use the cash flow all the way out here as my time 1, then that value at time 0 is as of year 5, isn't it? The year before this time 1. Year 5 is going to be before year 6, the year before time 1. By the way, thinking about time in a different signature is the most counterintuitive thing we're going to do in our class. I'm going to encourage all of you to not only watch the videos, if you haven't done so already, but to also participate in Monday night's review. It'll be helpful for you. Okay? So we've come up with this 20.2, and then we're going to discount it back to today. And if I take the present value of this continuing value plus the present value of these summation of these cash flows and add them together, I get a present value. So the present value of all of this in a model form is 16.62. Okay? Any questions yet?
So I just want to reframe to make sure I understand those a lot.
Good about doing that, Matt. Thank you.
Those four, PV, CV, PV values. So, okay, so PV, future cash flow, that is just the sum of everything in the column, the second to the right column that, then CV, future cash flows, that's basically just your Gordon growth model cash flow projection, I guess, or value.
Growth model construction of that cash flow's value.
Right. And then PVCV is you discounting it back so that you have basically the value that you would put next after 7.39. Is that right?
Exactly right.
Okay. And then what is the last number? Is that just the cumulative of 1 through 6 at that point?
But when you say the last number, you're talking about 16.62.
Yeah, sorry.
It's actually the sum of the present value of the cash flows during the explicit period, so 7.39, plus the present value of this continuing value. I can add an apple and an apple to get an apple. So this 16.62 is a present value. What did I tell you a business is valued at? The present value of its time and rate discounted expected future cash flows.
Gotcha.
Okay. Let me show this construction to you in a spreadsheet that I think I have right here. And thank goodness I do. My numbers are a little bit different because I'm using a different discount rate, okay? So I'm going to change this to reflect the same discount rate, and I think I've got the same growths here. Let me look at that real quick just to make sure I do. Yeah, just about. They're very close. Well, we're going to use this example. So what I've got set up here, and by the way, you'll see this kind of a spreadsheet in my my website, and it's one of the decision criteria templates. Okay, and what we have is I'm giving you what my base year is 2019. I'm telling you that the growth in years 2020 to 2024 is constant at 10%. That the growth beyond that is 2.5%. And that in 2019, we had a cash flow of 1.77. I'm telling you, I've got a tax rate of 26%. I'm not going to go through WAC at the moment, but you'll recognize all these numbers for WAC. They come from Mira Dravana. Okay? So, and by the way, this 1.77 comes from Mira Dravana as well, for that matter. So how do I get the 1.95 in this case? I take the, just a second. Yeah, I take the cash flow from the time before and I expand it at the growth rate. And that's what I'm going to do for each one of these. I'm just expanding it at the growth rate every time. So I take the year before times 1 plus whatever the growth rate is. And it gives me the next one. I do that year over year. And then I change that growth rate when I get to the end of my explicit period. And when I'm thinking about the next, I change that growth rate to this very normalized, vanilla pudding, very bland growth rate. This pattern is going to be repeated throughout all of our valuation modeling. I'm doing this only to come up with some cash flow. In the next call, go ahead.
Just a quick question, Rick. So just to make sure I follow kind of like, I guess, order of operations thinking. So obviously you have everything filled in here. So let's say, we go to start this and all we have is just the variables at the top to figure out the rest of the table. So we know from, like you said, our previous spreadsheet assignment, and it's listed there, the future cash flow 2019 is 1.77. So I'm just trying to understand, how would we have to calculate the 2020 free cash flow first before anything, right?
Well, you have to calculate your column of cash flows before you do the rest of this. Yes.
Okay, so all of them.
Uh-huh.
But just trying to understand how you said you got the one for 2020, because it looks like you used a different formula there.
Well, it only looks that way. Let me simplify this because I actually referenced this back to another sheet.
And that's okay, even if you just want to just say it conceptually.
I'm gonna make it real easy for us. So this times 1 plus this. So now the equational structure looks the same, doesn't it, Matt?
Yeah.
Okay.
But okay, so that G 2020 through 2024, is that for like when you do a problem like this, that's just a variable that's just given? Like that's not something
somehow would have to be given, yes, or you've got information that would lead you to it, yes.
Okay, and that's fine if it is. I just want to make sure I'm not missing something that
You've got it exactly. You got it exactly. So think about this. Kate and I are sitting looking at our company. It's Haskell Marconi Enterprises, or Marconi Enterprises, and we've looked at each year's growth, but we know that each year's growth is running around 10%. Next year we think it's going to be a little bit better because this year was horrible, and the year after that maybe not as much. But we're then going to sit down and say, okay, what we know is these are guesses. So Kate, if they're coming in around 10%, what do you say we just estimate 10% over the next 5 years? That's how you can think about this, right? And then Kate says, fine, Rick, but past 5 years, I'm not willing to think about 10% because I know that we don't know. We're getting too far out in time. We've got to slow this down. We've got to normalize it. I'm going to require that we come down to 2.5% because that's prudent.
Right. And when you're doing the reason I'm looking at this to ask questions, I'm thinking to myself, okay, well, how I calculate future cash flow is, or not future cash flow, free cash flow is, one of the 3 methods we used previously. But we're not really necessarily doing that here. We're saying we already have one to base all of our future valuations off of. We just have to, so the first part is just simply taking, one and adding whatever we project the rate is the first 5 years. And then, at the 6th year, that kind of generalized, growth rate.
Exactly.
But so it sounds like from there, the trickier part is then figuring out your present values and your sum of your present values and everything else.
Yeah, so what we're doing here, and this is important for all of you to kind of see our roadmap, and every once in a while I'll show you the next tabs in my model. What we're doing is we're creating a structure that when we know the cash flows and we know a discount rate, and then we can come up with a value. The next thing that we're going to do, and we'll do this next week, is we'll look at how do we forecast the cash flows. Well, I don't want you to spend much time here, but this is Mira Dravana. You'll recognize some of the numbers. And year over year, we are expressly calculating the free cash flows the way you know how to do them. It happens to be at a very different rate of growth. Okay? So I'm getting you used to a structure of what we're going to do with those cash flows, and then a very comprehensive and somewhat complex way of calculating the cash flows so that we can then come up with some valuations. See these models? See the structure of this model? It looks exactly like this structure, doesn't it? So that's what we're building together, okay? Hopefully that kind of helps you see what's happening. Well, let's move on with this, and more of this will kind of unveil itself. So I've calculated using a basic assumption. I have a cash flow in year, my base year. I'm assuming that my cash flow is going to grow at 10% in this case for 5 years, and I'm going to assume it grows at 2.5 years or 2.5% thereafter. So that gives me these cash flows. I'm going to take the present value of each one of them during the explicit period only. How do I get the present value? I take the cash flow divided by 1 plus the discount rate to the power of the time interval. That's the present value equation. Beta t divided by 1 plus r to the t. CF1 divided by 1 plus WACC to the power of 1. Or CF2, CF2 divided by 1 plus WACC to the second power. And so each one of these cells is simply the present value of this cell. And then in my third column, just as the header suggests, it's a summation. It's giving me a running total of those present value of the cash flows. Well, I didn't have anything before this one, so there wasn't anything to add it to. In the next one, I've got something to add it to. So 1.7 plus 1.63 is equal to 3.33, and so on, and so on, and so on, in a running total.
Hey, Rick, forgive my ignorance with this question, but when we talk about free cash flow for 2020 or any number in the future, then we're talking about present value free cash flow. I mean, if we're talking about present value in 2020 and 2021, like, to me, just on the surface, that seems contradictory. What am I missing there?
Okay. So, Matt, this 214 is not a present value as you and I are looking at it here in early 2020, okay,
Right.
for the end of 2019. That's a future value, right? Okay, it comes at us in year 2021. But its value at the end of 2019, the last period for which we have good numbers, its present value would be 1.63. So its future value in 2021 is 2.14, but its value as of the end of 2019 is 1.63. Its present value. So the present value of this future cash flow, which is estimated for 2021, is 1.63. Does that help?
I mean, kind of. I'm just trying to think of it in practical terms as far as what it actually means. So you're saying, okay, my, yeah, I don't know. I'm still a little lost.
I can help. So Taylor has come in and he has said, Rick, we've estimated that we're going to have free cash flow 2.14 in the year 2021. And I said, Taylor, I think that's great. But brother, I am all about the here and now. I'm a market-driven guy. What's that 2.14 mean for me today? I said, well, Rick, we've got a 14.47% discount rate. That 2021 is 2 years out. What it means is it's got a present value of 1.63.
I think, Matt, for me, where it gets counterintuitive, and I don't know if this is the same for you, is like you think, okay, well, I'm not even getting that money till 2021, the 2.14, because it's in the future, so isn't that zero right now? But realistically, yeah, we don't have that money, but that money's value, if it were to be in this moment, would only be 1.63.
Yeah,
Even
I think
though that's where I don't know if that's where you're coming
That's a great way of putting it, Mandy. It's a really great way of putting it.
I think how you said it clarifies it. So what I keep getting caught up on is we're still talking about the year 2021 with both of those values, but I get what you're saying is that, well, if you want to know, you know, what amount of value it's going to take to project out to that number, 2.14, this is what it's going to be, is 1.63, I guess.
Right. Or another way of saying it, Matt, I will give you $2.14 in 2021, or I will give you some amount of money today that is equivalent to $2.14 in 2021. How much is that amount? And you're going to come back and say, well, I discount money at 14.47%. That's 2 years from now. I can then run the number and say, okay, so $1.63 today is the same thing as $2.14 in 2 years.
Right. And I think also what trips me up is thinking of it, watching it go year after year, thinking of it in a continuum, when really you're just projecting year after year so you can see a trend.
Yes.
You can take that and like you said, you could use any of those and say, okay, here's what it discounts back to. Here's what it discounts back to.
Yes.
It just depends on how far ahead you want to project.
Yes. And
Okay.
each of these numbers, 1.7, 1.63, and so on down to 1.45, each of them are the present value of the number in the column to the left. And this number in this column D is the expected future cash flow based upon us starting at a 1.77 and expanding at 10% a year. And when we move to 2025, the expansion changes to 2.5%, no longer 10%. This is a multi-columnar construction. Okay, I'm going to show you the algebra behind this very quickly just so I can bring us back to something that we've seen. The present value is equal to the sum of the free cash flows at different time intervals divided by 1 plus a discount rate to the t. That's what we're looking at right here. That's the summation. These are the present values of these cash flows at this rate during these periods of time.
And I guess the practical use for this, just to kind of simplify it a little bit, is going back to kind of just the whole concept at the beginning of, okay, what's your money going to be worth to you in the future, right? So in this model,
just the opposite. What's future money worth to you today? Because this business that we're thinking about investing in, so my investment advisor, Mario, has come to me and said, Rick, there's an investment and it's owned by Kylie Erickson. It's a company and it's got projected cash flows of 1.95, 2.14, etc. during these years in the future. I think an investment in that company is a good idea today. And I'm just going to say, fine, Mario, what's the present value of the company? And Mario runs all these numbers. And he said, well, based upon everything we know, its present value, which is the sum of the present value of its expected cash flows discounted for rate and time, its present value is 20.28. And I say, Mario, I think that's an interesting number. I'm willing to offer 20 for that. Because I always want a little bit more, right? Even though Mario says it's worth 20.28, I always want to offer a little bit less. Because I know Kylie's a shrewd negotiator, and she's going to try to bring me back up to a number bigger than 20.28.
I see. So I think, that's a really good point. So I think what I was thinking was, I keep getting the mindset, and I think this is why my mind's taken a minute to wrap around this. I keep thinking strictly from the whole investment standpoint, right? Like, well, if I put in this much money, what's it going to be worth? And I think what you're getting at is, if you're evaluating a business, or really any investment opportunity, but let's say a business in this case, because we're talking about all the things that make up a business and its value, and someone says, well, here's what its potential is with all these future cash flows, you need to be able to identify and say, okay, well, does that make sense, or what price makes sense for me to pay for that? Or what is its actual value? And that's what you're saying by it's the exact opposite of what I was saying, because you need to be able to evaluate, well, is this a good deal or not? Does this make actual financial sense for me?